Hello and welcome from Omnes Res. Today we will be attempting to make the best Kaplan-Meier plots in the entire world. That's correct, the entire world. So what is a Kaplan-Meier plot? Well, you can just go ahead, do a little Google search, Kaplan-Meier, look for images, and here you go. So Kaplan-Meier is a popular way for showing survival data. And there's different software out there to make them. But to be honest, I'd be a little bit embarrassed to have any of these in one of my publications. So today we're going to be investigating different ways to plot Kaplan-Meier curves and to see if we can make them presentable. Okay, so one way to plot Kaplan-Meier plots is to use R. R has a very well-known survival library. So if we open R, I have some data, Kaplan.txt. We can take a look and see what that looks like. I have it right here. So you have the first row is just the labels. This is time in days, and the patients either died, one would be died, 0 would be censored. Basically, the study hasn't gone on long enough for them to die yet, so the data is censored. So we have those two different values, and this column just tells you if the data is censored or not. And then you have two different groups, and I put these patients into two different groups on my own. Okay, so you can just load that into R, but first we're going to load the survival library. To read data into R, you can just do read.dlem. We're going to make a survival object and then use the surfit function. And then we're going to plot with some colors, and then we get that. So that's the default R graphing for Kaplan plots. It's decent, but it's not the best. I mean, the axis has this weird thing here. I don't know. The lines aren't really as thick as I would like them, and you can change some of these properties. And these numbers, I'd prefer the numbers to be probably horizontal, but that's just my preference. So it's true that there's another way to plot in R. So there's ggplot, which is a very popular plotting package. So let's load that. And then I copied this code off the interwebs. It's just a function, and then we have to call that function. And then I did do a bunch of aesthetics here. Actually, I'm going to just use the default size to start. For the lines, and let's see what that looks like. Let's see, zoom in on that. So that's what it looks like. It's a little hard to see, so I'm going to go ahead and call this PDF right here and save it as a PDF. Then I'm going to go ahead and open that. So, I mean, it's decent. I don't really like the curved lines that it makes. And then I changed the thickness of the axes, and then look what happened. Look what happened here. And the axes just don't really look that great. I mean, you've got this extra thing hanging off over here. I don't know. I would prefer if it ended in a tick mark. Maybe you can change that in ggplots. I'm not really too sure. And then the size wasn't super great, so on the geom step, I can change that, and that will make the size a little bit bigger. It looks a little bit better, but still not super great. So what can we do? Well, if you want something done right, sometimes you have to do it yourself. So we are going to attempt to make Kaplan plots on our own. So we don't really know how to use R that well at Omnes Res. I mean, we know the basic functions and we use RPy a lot. But we dream in Python code, so we're going to go ahead and see if we can use Python to make some pretty sick Kaplan plots. So first thing we're going to do is open that file we just had, kaplan.txt. Get that thing open. We're also going to be using Pylab. Pylab is a very popular module in Python for plotting. So we're going to use Pylab, and we're going to be just opening that file. So in Pylab, what we're going to be using is the hlines function, which is going to take a y coordinate and then 2 x coordinates, and it's just going to plot a horizontal line. And we're also going to be using the vertical lines function. I mean, a Kaplan plot is basically just horizontal lines and vertical lines, so that's all we're going to need to plot Kaplan plots. So now we need to read that data. So let's look at that data one more time. So this is our file. This first line, I don't need that first line. So I'm just going to do a f.readline. Then I'm going to go ahead and just do a list comprehension here, where I strip off the new line character at the end. Then I split on the empty space. And then I just do that for each line in F. And then now that I have that I have my data nicely split, I'm going to go ahead and make this variable serve times another list comprehension. This time I'm actually going to do some stuff to the data. I'm going to int the time. So right now it's a string, which is not very useful for us. We need to make it an int, which is basically just a Python number. And then we're going to int the other one as well. Oops, that's what I want right there. And I'm going to only plot one group at a time. So if the last value in the row equals 1, then this list comprehension will occur. So I'm going to do one last thing. When plotting Kaplan plots, you're going to want your data sorted. So I'm going to sort this, but I have to do a special sort. So I want to sort by the first column and then the second column. I would like it if the censored data came before the deaths. So I'm going to use a lambda key here to do that. I'm just going to go ahead and do lambda x, and then I'm just going to do first column, second column, and that should hopefully work. Yes, so for I in serve times print I. There we go. So sorted by the first column, and if we ever have a case where these numbers are the same, then it'll do 0 before the 1. I don't know if we have that case or not with this data. Okay, great. We have loaded our data, but now the hard part begins. So before we attempt to plot, we have to see if we even understand what we're plotting. So going back to these images, you have this y-axis. It's percent surviving, that's what it's normally labeled, but it's not quite just percent surviving. It's actually a little bit more complicated. So I'm just going to try and explain. So what the y-axis actually is the probability of surviving at that time, and that equals the probability of survival right before time t and the probability of failure at time t, which is the probability of survival at time t minus 1 times the remaining subjects at that time t minus the subjects that failed at time t divided by the remaining subjects at time t. Yeah, it's a little bit complicated, but that's what we're going to have to use to get our y values. So just I'll come back to that formula. Okay, so we are ready to start making some functions here. So I'm going to go ahead and define a function called Kaplan. It's going to take our serve times, which are these right here. And to make a Kaplan plot, we only need three things. We need the coordinates of the horizontal lines. We need the coordinates of the vertical lines. And then we need the lost to follow up vertical tick marks. So I'm just going to make three empty lists. And then we know that y, the first y value is going to be 1 because everyone's surviving. And we know the first x value is going to be 0. So we're making some progress here. Then I'm going to loop through those serve times. And if I1, right here, I1, if it does not equal 1, lost is going to get some coordinates here. It's going to get the x value, and it's going to get the y value. And well, y equals 1, so that's just going to get a 1. And x is going to be these x coordinates. And then we're going to keep on doing that until we hit an actual depth. So if you look at some of these plots, you don't take a step until someone has actually died. So you can have as many tick marks as you want, but then someone has to die in order for you to actually take a step down. So a bunch of stuff happens once I1 equals 1. And so we have to do all that stuff right here. I'm just going to use an else statement since I only have two possibilities, 0 or 1. And we're going to get some horizontal coordinates because we need to make a horizontal line whenever we have a step. So we're going to append the x coordinate and the y coordinate. Y actually needs to change, and now that's where things get complicated. So we gotta go back to this formula. So we have to use the previous y, which in this case is just 1. And then we have to use remaining subjects minus failed, divide by remaining subjects. So what is that? That's just going to be the length of our list with the index. So we're going to find the index that we're at right now. We're going to do index I. So we're going to find where we are in our list. And then we're going to add 1 to it, which is basically subtracting 1 from the length, because we moved one index forward. So if you go back here, minus failed. So every time this loop hits a death, that's 1 death. So that's -1. And we're doing -1 by just adding 1 to the index that we're currently at. Pretty sneaky. Then we're going to divide by float length. You guessed it. I'm just going to have to make this full screen now. Attempt to make it full screen. Here we go. Serve times dot index I. We're not going to add 1 this time because we want the full subjects remaining to the end. Length float. I did a float here because if you have integers with Python, you have like this weird thing where I'll show you real fast. If you're a Python user, you know about this. So like 4 divided by 5, oh my god, it's 0. So that's why you have to do a float. So if you do 4 divided by 5.0, you're good. So that's why we floated there. Now we made our y. Now we're also going to make our vertical coordinates. And that's just also going to be our x value. And the vertical coordinates, so it needs an x value, then it needs two y values. So it's going to be the previous y value. And to get the previous y value, I'm going to take the previous horizontal coordinate value, which in this, the previous y value that's listed in the previous horizontal coordinate. So you take the previous horizontal coordinate, get its y value, it gives me, that's the previous y value. In this case, it's 1, because we set y equal to 1. And then the current y. So the previous y and the current y, and then the current x, and that's how you draw your current vertical line. And just append that. And then we also, yep, that's it. Now we're just going to break out a loop there. So now we're going to make a new serve, because we want to do this loop over and over again. So that was just the first step of the loop. That was just, we just got to, oh, that's not my sorted data. We just got to the very first death. We got to here. That's all we got to. We need this to repeat itself until we get to the very end of the file. Or the list in this case, because we load the file already. So to do that, we're going to make this new serve, which equals serve times. Serve times, you probably guessed it, we're going to get the index. And we're going to add 1. So that just basically finds where we are right now in our list. So we're here. It finds that position. Then it adds 1 to it, and then it starts here. So now we're going to be starting here the next time through the loop. But if we want to go through the loop again, we're going to have to type something right here. So we're going to go ahead, and we want to do that loop until new serve is empty. So until new serve is empty, we want to just keep on doing that loop. So we're going to set new serve y horizontal coordinates, vertical coordinates, and lost. We're going to set that to the loop. I'm going to make a function called loop, which is basically the previous loop. And it's going to take new serve y h coordinates, v coordinates, and lost. And then once the function is finally done, it is going to return the 3 things we need: horizontal coordinates, vertical coordinates, and lost. Okay. So now all I have to do is make that loop, and then we will be done. And as I just said, loop takes all of these things. So I like to mix up my variables a little bit, because sometimes Python will remember a previous variable. I don't think it's going to be an issue here, but instead of I, I'll just start using j. So for j and new serve, so I'm just basically copying what I had before, but instead of serve times, now I have new serve. Instead of I, now I have j. If j1 does not equal 1, lost dot append j0. Gonna need to make this a list. Y. Else h coordinates dot append j 0 y. Now here's where we have to set our y again. So before we had y times this beast, but I put 1 here because I knew that y equals 1, but really it should be y. So it's the previous y, and I was just making a point by saying that the previous y was 1, and that's why I put 1 there. So it's the previous y times, I'm just going to copy all this. But instead of serve times, we need new serve. So every time we see serve times, we need new serve. So we can just copy that. So yep, there we go. And vertical coordinates dot append j0, the previous y, which we're getting from the horizontal coordinates. Actually, I just realized I could probably just, if I made the vertical coordinate before I redefined my y, I wouldn't have to do this. But we'll be a little fancy, like a little flair to the code. And then we'll just break again as before. And then new serve equals new serve dot index j. Hope I've been using j this whole time. No. Oh god. Yeah, so whenever you copy from other places, horrible things can happen. There we go. +1. Go to the end. There we go. And then I just need to return all the good stuff. Let's see. Yep. I hope everything's good. We'll check. So I'll say kplot equal to Kaplan serve times. Let's cross our fingers here, see what happens. Okay. So we're gonna see what we have. So for I in kplot 0, so I'm just going to be looking for the horizontal line coordinates. And, oh, yeah, that always happens. Print I. Yeah, so the first horizontal coordinate is going to go from 0 to 61. It's going to be at y equals 1. Then it'll be from 61 to 76, and it'll be at this y, and so on. So that looks great. Let me check the vertical coordinates. Those also look good. Check the lost coordinates. They lost a follow-up, a bunch of them. Yeah, so that looks great. Okay, so we are ready to start plotting. We have our coordinates. Now we just have to plot them. So in Python, in Pylab, there's 2 ways to plot. You can either do plot dot something, or there's a more complicated method where you create a figure and an axis object, which I'm actually going to be doing because it allows you to have more control over the axes properties, which you might expect. So we're going to go ahead and start plotting these. So we're going to make this variable called start. We're starting at x equals 0. And for I in kplot 0, so the horizontal line coordinates, we're just going to loop through all those. We're going to do axes dot horizontal lines. We need to get the y value here. The y value is going to be the second value Python coordinate 1 in my horizontal coordinates list. And I've been using decimal places, but I kind of want percent, so I'm going to multiply by 100. And then the start, which is going to be 0 in this case. And then the x-coordinate. And that's all she wrote. Okay, so then I need to change start now to be I0. So start's going to constantly change and update itself. And you know what? Let's just see what we have. Plot.show. There we go. So that looks awesome. So those are our horizontal lines. Now let's get some vertical lines here. So I have to do kplot1 because that's where our vertical line coordinates are, and I'm going to do axes dot vertical lines this time instead, and I'm going to do I0, which is see, it's nice enough to tell me that's the x coordinate, and then I need the y min, which is just going to be I2 times 100, and then y max, which is just going to be I1 times 100. And those are the vertical lines. So we could go ahead and see what that looks like. Ooh, look at that. We just made a pretty sick Kaplan-Meier plot. But I did promise the best plot in the world, so we're gonna keep on chugging here. So let's get our lost to follow-up coordinates. So kplot2, that's where those live. We're going to do axes.v lines because these ticks are vertical lines. Actually, I could use any sort of Python. I could use other Python functions here, and I can make those, instead of lines, I can make them like stars or circles or whatever I wanted to make them. Let's see, so just as before. So we only listed one coordinate for the vertical lines, just the y coordinate. But to use the vertical lines function, we need two y coordinates. So we're going to take that one y coordinate that we have, which is I1, and then for the y min, we're just going to subtract a little bit, and then we're going to multiply by 100. So effectively, what we're doing is we're making the vertical line a length of 2. If that length isn't good enough, you can just change what you subtract and add by. There you go. Oh, now look at that. We have this very interesting thing happening here where we don't have a horizontal line here. Now, why is that the case? So that's the case because we only make a horizontal line when we run into a death. So if our data ends in sensor data, then we never made a horizontal line. So we have to actually manually go about that. So I have some code which will deal with that. Let's go ahead and paste that in there. There we go. So basically what it's saying is if the censored x value, if the last censored data, the x value of that is greater than the last x value of a non-censored data, basically the horizontal line, then I have to add another line and see if this actually helps us. Yes, we now have a horizontal line there. Now this plot still isn't looking like the best Kaplan plot in the world, so we're gonna have to do a couple more things here. As I said, the axes object allows you to control a lot of properties, and I'm just going to go ahead and paste some nice properties in here. I'm also going to change the limits a little bit. I'm going to change the y limit from 0 to 105, and then x limit just start at 0. And this is going to do a lot of really nice things to our axes. So let's see what that looks like. There we go. So I made the axes thicker, I made the ticks go outward, I controlled the spacing of the ticks. I have the final tick perfectly at the end. Let's see, let me just go ahead and save this as a PDF. Let's open that thing. So even if you zoom in, like all these lines are just perfectly connected. They just look beautiful. These lines don't look super beautiful yet, and they don't even connect correctly. So we're gonna have to do a little more work here. We're not done. So first thing we're gonna do is let's get a width here. Let's increase the width of our lines. So now everywhere I'm just going to do line widths equals width. I'll just go ahead and copy that. Okay, let's see what that looks like. Did I close my other plot? Yeah. Okay. Yeah, so now the line width is a lot better, but the lines still are not connecting. So we have to actually move the lines depending on what our width value is. It's really kind of annoying, but I have a very rough formula for this. Basically, what I'm going to do is for the vertical lines, I'm going to try and take into account the width variable. Let's see, I'm going to multiply it by 67 divided by 1,000. I did like a rough estimate visually. And then I'm also going to add that to the other coordinate. Okay. Now let's go ahead and save that. PDF. Overwrite. Okay, so let's see what we got here. They're still not quite there. Let's see what we can do. Let's try 70, 71. You'll have to play around with this depending on the width that you choose. I'm sorry about that, but you just try a couple numbers. Doesn't take too long. Let's see if that did the trick. It's worth it. Let's see. There we go. That's pretty good. I mean, if I wanted it to get better, I probably could, but looking at this distance, you can't really tell. So I mean, I'm okay with that number. Okay, so we're in business. So now what we're going to do is we are going to add some color to these lines. So I'm going to color those blue. Just color everything blue. And then what I'm going to do is copy. Yep, just copy that whole thing there. And we're going to get the rest of our data. So we only did one group, but we had a second group which we need to plot. So I need to reopen the file, get serve times, but instead of 1, I need a 2 here, and then I need to make kplot again. But I don't want both lines to be blue. I want to be able to tell which line's which, so I will change this to red. There we go. Let's see. Okay, let's see if that works out for us. Look at that. Let me just save that thing. Okay. So that's what we have. As you can tell, the lines are pretty flush. The thickness is good. I like the right angles. I prefer that over the curves. The axis is as beautiful as it's gonna get. You can compare this to the ggplot, Python, ggplot, Python. Now, if this isn't the most beautiful Kaplan plot you've ever seen, let me know in the comments below. If there's other problems you'd like us to tackle, also let us know. And all the code seen today is available at Omnes Res. Please check us out. Thank you very much.